Okay, welcome to part two of hyperbolas, where we take a look at the actual math involved. Now, we're going to go through three problems, and I would encourage you to pause the video and try a lot of these out for yourself. So the directions for the first two problems will be, I'm going to give you the equation of a hyperbola, and I need you to find the center, the vertices, the foci, and the equations of the asymptotes for the hyperbola. And I also would like you to sketch what this hyperbola looks like. So here's the first equation, 4x squared minus y squared plus 8x plus 20 equals 0. And you can see that this is not the form that we want it to be in for a hyperbola. So we're going to have to do some work where we complete the square. So why don't you maybe pause the video and give that a try and see if you can complete the square for this. Well, welcome back. Hopefully you completed the square successfully. Let me walk through what I did. First thing I did is I grouped my x's and I grouped my y's, and I took this constant of 20 to the other side. Now to complete the square, I want no number here other than a 1, so I factored out a 4. I just went ahead and made this minus y squared equals negative 20. So to complete the square, I figured out that I need a 1 inside the parentheses, but realize that's not really a 1, it is a 4. So if I added 4 to the left side, I'd have to add 4 to the right side, and I end up with this. So we've completed the square successfully. Now in order to get this in our general form, I need this number right here to be a 1. And how do you make that a 1? Well, you divide both sides by negative 16. And what's that give us? Well, it gives us a 1 over here, but when you take a negative divided by a negative, you get a positive. So that's why I chose to put the y squared first, because it's positive. And of course, a positive divided by a negative is a negative, which is why I put the x squared second. So one thing that we can tell right off the bat is this is going to be a vertical hyperbola, because the y squared is positive, the x squared is negative. But that's not going to come into play for a while. First thing I did is I found the center, and you've seen this sitting over here, so this was no big surprise. But the center, ta-da, is negative 1, 0, negative 1, 0. So I can say this center, negative 1, 0. Now, here's how you graph a hyperbola. It's very important that you find the A and the B, because the A and the B are going to set up our fundamental rectangle. And the fundamental rectangle, you remember, helps us draw those asymptotes in. So A is 4, B is 2. Now remember, A is not necessarily the largest number. A is under the positive variable. So in this case, A is 4. And since that 4 is under the y, that means it's my vertical movement. I'm going to go up 4 and I'm going to go down 4. B is under the x in this case, so B is 2. So that means I'm going to go left 2 and I'm going to go right 2 because, well, it's associated with the x. Now, these values right here represent my length and my width of my fundamental rectangle. So you can see that the fundamental rectangle is going to have a total height there of 8 and a total width there of 4. So off here to the side, I can sketch in this fundamental rectangle. Now, why is that fundamental rectangle necessary? Because if I draw a line from one corner to the opposite corner going through the middle, and I draw the other line from one corner to the opposite corner going through the middle, I have just drawn the asymptotes. And those two asymptotes are going to frame in my hyperbola. Now, we've got to figure out, how do we draw this hyperbola? Do we draw one going sideways, framed in from those asymptotes, or do we draw one vertically, framed in from those asymptotes? Well, the determining factor as to whether this is a sideways hyperbola or a vertical hyperbola is which variable is positive. Since the y is the positive variable, it's going to be a vertical hyperbola. So I'm going to grab my pen, and I have practiced this quite a bit, and it's been awful every time. I need a mouse. I have this trackpad, but The hyperbola is going to be vertical. So I'm going to hug the asymptote and I'm going to swing right down here to this vertex and go right out to that other asymptote. And that is okay. And then I have one down here. Along the asymptote, hits the vertex. Okay, that didn't work out very nicely. And then back along there. Oh, heavens. That's terrible. Now, if this was an x squared minus y squared, we would have drawn one side to side. And if this was y squared plus x squared, it'd be an ellipse. And the ellipse would simply be inscribed inside this fundamental rectangle. Major axis 8, minor axis 4. Now the vertices, remember, are the points closest to the center. And so those vertices we could find now by going from this point, -1, 0, up 4 and down 4. And the foci, remember we get the foci by this equation, a squared plus b squared equals c squared. So a squared we know is 16, b squared we know is 4. That gives us a c squared value of plus or minus radical 20, or a c value, and we can clean that up to plus or minus 2 radical 5. So we know that we have these foci located there and there. And again, the foci are always going to be lined up with the vertices in the center. And finally, we need the equations of the asymptotes. Now these asymptotes are lines, and there are 2 of them. So I'm going to go back to that way I've always written equations. So I'm going to write y minus something equals the slope times x minus something. This is point slope form. Well, I know that both asymptotes pass through the point -1, 0. So -1, 0. And what's the slope? Well, the slope of these asymptotes, look, it's a rise of 4 and a run of 2. Or it's a rise of -4 and a run of 2. So my slope in this case is plus or minus 4/2. And all you have to do is just clean this up a little bit and you're done. Those are the equations. This is the quickest, easiest way to write the equation of a line. Well, let's try another one. Here's my other one, and what I'd like you to do is I'd like you to take a second on your own and just complete the square. Hey, welcome back. Hopefully you completed the square correctly. I'm going to just walk through very quickly what I did. I got the x's together, I got the y's together. I pulled the 9 out because I want this just to be a 1x squared, and I pulled a -4 out because I want this to be a 1y squared. This needs a +4, which is really 36. This needs a +9, which is really a -36. And I end up getting this. 9 times the quantity of x minus 2 squared minus 4 times the quantity of y plus 3 squared equals 36. But remember, this needs to be a 1. So if we divide both sides by 36, we end up with this. And I hope that's what you got. Now, you'll notice the center is 2, -3. Spoiler alert, I had that there the whole time. And then let's go and figure out what we do from here. We want to draw our fundamental rectangle. So we notice that, let me just come over here, that this value right here, this a value is 2 because that's 2 squared. We know that this b value here is 3 because that's, whoa, geez, 3 squared. Oh my heavens, 3 squared. 3 squared. And so that means since this is 2 squared, I can come out here left and right 2. Since this is 3 squared and it's under the y, I can go up and down 3. And then that gives me enough to draw my fundamental rectangle in. And since I have my fundamental rectangle, I can connect those diagonals and I can get those asymptotes. So we have those, the whole setup ready to draw the hyperbola. All that's left is I need to figure out, am I going to draw a side-to-side hyperbola or a vertical hyperbola? Well, since the x is positive and the y is negative, that means it's going to be a side-to-side hyperbola. So I'm going to hug this asymptote. I'm going to come right along here. Oh, geez. Right along here. And I'm going to... Oh, all right. This is one of the worst ever. This trackpad is terrible. I'm going to come right along here. Oh. And I'm going to get out and hug this Oh, my gosh. Struggling. There we go. And we get our side-to-side hyperbola. The vertices, well, remember the vertices, that's the shortest distance from the center to the hyperbola. So we have a vertex there and a vertex there. You are coming from the center point to -3. You're going left 2 and right 2. The foci, we know a squared plus b squared equals c squared. 4 plus 9 is 13. So c is plus or minus radical 13. We know the foci are located inside these curves, so we add it to the x. And finally, look at the equations of the asymptotes. We know the slope is either up 3, right 2, or down 3, right 2. So we can pick this center point, and we can say, okay, we know that that center point, it passes through 2, -3, and we know the slope is plus or minus 3/2. And that's perfect. You can leave it just like that. Finally, one last problem, and it's if we reverse it, and I give you some information about the hyperbola, and I want you to give me the equation. So in this case, why don't you pause the video and see if you can sketch out some of the things that are going on, and maybe you can figure out the equation for yourself. Okay, so welcome back. I know the vertices here are 8, -2, and 8, 8. Now, some of you on your homeworks are not really thinking this through. These are on top of each other. They're not side to side. So I know these are the vertices, and that means that the fundamental rectangle is going to pass through these vertices, so I can sketch out that fundamental rectangle. And since these are the vertices, I know that the exact center of these two vertices is the center of the hyperbola. And I also know it's a vertical hyperbola here. So I can come up with actually this equation. I can say, where is my little equation here? All right, I think it's here. I can say that it's a hyperbola, so I know it's something minus something. And since it's the vertices are vertical, I know that it's a y minus x. And again, I threw in the 3 for my k and the 8 for my h. So I have most of my equations set up. Now I just have to figure out, okay, what goes underneath the y and what goes underneath the x. Well, look at these asymptotes. You see this slope, 5/4? Notice that the distance going from 3 to 8 is 5. And that's the rise. That's the slope of the asymptote. And this 4, well, that's going to be the horizontal distance. So the rise is 5, vertical, so that goes under the y. The run is 4, horizontal, so that goes under the x. Well, that's it. Good luck on your homework, and feel free to email me your questions.